माचिस की तीली जलाएंगे
और बुझने से पहले अगर तुम सब लोग यहाँ से नहीं निकले तो सबको एक साथ एक ही जगह पर जला के राख बना देंगे।
Once more, it's that season when meteorologists expect La Niña to set in. In only half a month, it may potentially bring us a harshly cold and turbulent winter. But what exactly is El Niño's cool sister about? How does this natural anomaly develop, and what impacts should we prepare for in the future? One thing is already clear. Although El Niño and La Niña are generally regarded as the major players in global weather patterns, we shouldn't overlook the polar vortex, which also has a significant impact on the weather at our doorstep. Indeed, the exceptional interaction of the polar vortex and La Niña might this time ensure that we are in for a winter completely unlike those of the past. Droughts, severe flooding, and sudden temperature fluctuations are, unfortunately, becoming more frequent with an alarming level of certainty. According to experts, these extreme weather events are also becoming increasingly likely. Researchers don't need to look far for the reason behind this unwelcome trend. Climate change has already increased average annual temperatures globally by 1 degree Celsius between 1881 and 2019. In this country, the increase over the same period is as much as 1.6 degrees Celsius. The 10 hottest years since regular weather records began have all been measured since 2010. However, even the outlook for the future cannot be described as particularly optimistic. Experts predict that, regardless of whether we succeed in quickly halting the warming of the Earth's greenhouse effect, certain climate-related changes can no longer be averted. In Germany, the associated increase in extreme weather events is particularly linked to the risk of storms, extreme heat, heavy precipitation, and resulting flooding. We only need to recall the 100-year flood of 2021, which claimed the lives of 180 people, 135 of them in the AHR Valley alone, and caused billions of dollars in damage. At the same time, the disrupted climate during winter also causes sudden temperature drops that are as surprising as they are abrupt. Although we have mostly longed in vain for a winter wonderland covered in snow and ice in recent years, the United States faced an exceptionally cold spell in December 2022 that claimed at least 63 lives. In February 2021, the situation in Texas was even more dramatic. The lowest temperatures in 30 years claimed 250 lives. Despite steadily rising average temperatures, meteorologists point out that such events are not isolated cases. On the contrary, according to the National Centers for Environmental Information, the frequency of extreme snowstorms has increased in 2/3 of the eastern United States. While this data specifically pertains to the U.S., scientists emphasize that similar developments can be observed in other parts of the world. But why is that so? What are the reasons behind this apparent climatic contradiction? How can a planet that is actually getting warmer experience dramatic cold spells and sudden ice storms at the same time? To understand how El Niño, La Niña, and the polar vortex influence weather patterns, we need to delve deeper. Recently, atmospheric physicists announced that they had identified the true culprits behind these often paradoxical weather phenomena. According to them, the interaction of the polar vortex, El Niño, and La Niña appears to be responsible for the extreme events of the past. Before we delve into the possible future implications of these phenomena, let's first clarify what these terms actually mean. Experts use the term polar vortex to describe the low-pressure vortices that exist at high altitudes over the North and South Poles. These vortices intensify during their respective winters, which is unsurprising since the lack of sunlight prevents the air from warming up during this time. As a result, cold air accumulates, and the westerly wind systems associated with the polar vortices intensify. Normally, the winter polar vortices remain stable over the poles. However, if the polar vortex weakens, for instance, due to a significant warming of the stratosphere, or if it fractures, the circulation within the vortex weakens and eventually becomes unstable. Consequently, trough-like formations can develop, potentially leading to a polar outbreak or, in simpler terms, a movement of extremely cold air masses. When it comes to El Niño and La Niña, they can be likened to a hot brother and a cold sister. Technically speaking, they are two circulation anomalies. To understand the effects caused by these phenomena, we must first consider the typical conditions. Generally, the circulation of the ocean and atmosphere in the tropics follows a predictable pattern. Because the sun's rays strike the Earth more directly near the equator, the air masses there warm up especially quickly. They rise and move toward the poles, where they sink over the tropics and then flow back to the equator. However, since the Earth rotates on its axis, the resulting Coriolis force deflects the air masses westward as they flow. These factors mean that the water of the Pacific Ocean off the Peruvian coast is usually about 10 degrees Celsius colder than in Indonesia. During El Niño events, which occur on average every 2 to 7 years, the climate system is turned upside down. The Pacific region near Asia and Oceania cools, while temperatures in South America continue to rise. The atmospheric pressure pattern is reversed, weakening or even reversing trade winds. This allows warmer waters to accumulate in the eastern Pacific. After El Niño weakens, La Niña typically follows, amplifying the normal state of the Pacific's climate system. Trade winds strengthen, and ocean temperatures in the western Pacific rise even more dramatically. These phenomena have far-reaching effects. For instance, El Niño years bring droughts to southern Africa and increase the risk of heavy rains and flooding in eastern regions of the continent. On the other side of the globe, Australia and Indonesia face dry periods and wildfires, while Peru and Ecuador experience rain, floods, and landslides. La Niña, in contrast, often brings cooler and wetter weather, which is why it is sometimes even considered a positive phenomenon in regions like southern Africa, Southeast Asia, and Australia. However, La Niña is also associated with significantly colder winters in areas such as Western Canada, the northern United States, Japan, and the Korean Peninsula. So, what about Europe? While the direct effects of El Niño and La Niña are minimal here, their interplay with the polar vortex could lead to significant weather disruptions. Currently, meteorologists forecast a 71% likelihood of a La Niña event this winter, potentially lasting until spring. This, coupled with the polar vortex pushing cold Arctic air toward Europe, could result in much colder temperatures. Although weather models such as ECMWF and GFS provide conflicting predictions, one hinting at snow and cold spells, the other suggesting the warmest winter on record, both agree on one thing: we should prepare for significant weather changes. Extreme temperature fluctuations and, potentially, freezing temperatures with heavy winter conditions could still occur. Ultimately, only time will reveal the true nature of the coming winter.